I think we discussed the atomic mass again, right? The topic of atomic mass again. Yes?
Yes, ma'am.
Okay. I hope there should be no confusion in it now. No confusion?
Yes.
Fine. Rishikesh, any problem in the third chapter for you specifically because you joined in late?
No, ma'am.
Fine. If there's any problem, please convey that without any hesitation. Okay. Now, let others join. Then I have to convey one thing here, and then we'll be starting with the fourth chapter. Fine. With the fourth chapter. Mohammed,
Yes, ma'am.
what is the atomic mass? What is the atomic mass for nitrogen?
Is it 32?
It's 14. 32 is for
No,
sulfur. No
no,
worries.
I was thinking about 14, but I thought that's oxygen, but then I remembered 16.
Yes, good. No worries. By practice, you will learn it. My main question here is that what does it indicate if I say the mass of the atomic mass of nitrogen is 14U? What is it indicating? Okay, my main question is this.
It's it's the 14th part of carbon 12 atom.
No.
Now
Rishikesh, any
explain.
idea? No, I will not explain it today. I remember this very clearly. I gave this last point. We'll not be discussing this again. Like I'll not be explaining this again, huh? Because I've explained this like 3 to 4 times now. Rishikesh,
Yes, ma'am.
any idea? What
Ma'am,
what what is it? Huh? Say that.
it's 1/12 of the carbon atom, so it will be
Mm-hmm.
equal to 14.
Okay. Not a very satisfactory answer, but somewhat in between. You are saying two things separately, not really mixing them. Fine. Let's quickly come to the basic point then. What is atomic mass unit? What is atomic mass unit? Ali, try it.
Atomic mass unit is a it's a value taken for
Mm-hmm.
as the carbon is it's like a
Mm-hmm.
part of carbon atom. It is like as the
Mm-hmm. Universal what?
universal atomic mass unit.
My question is, what is atomic mass unit? What is the need for that atomic mass unit? Why are we even taking that as the atomic mass unit? What are we taking as the atomic mass unit? And once we have taken the atomic mass unit, what are we doing with that unit? My
Ma'am,
question
the
is,
atomic mass is measured with the with the carbon 12 as a standard, right?
huh? Hmm.
So atomic mass unit would be
Hmm.
Is it like one atomic unit is equal to 1/12 of the carbon? No, 12th of the 12th part of the carbon.
Hmm. I'll not repeat it from my side. You will keep on guessing and I'll keep on asking. Did you not revise it? Tell me. Honestly.
No, ma'am.
Why?
Ma'am, I have my other exams now, so I've
Fine.
been studying.
Hmm. Fine, then you will revise it, and then whenever you will have any question, I'll be there to solve it. But the condition is, the point is, when you have revised it. Fine? Okay with it? I hope
Yeah.
you should not have any problem with this point.
Okay, ma'am.
Because then there is no point of you explaining it again and again once you are not really studying it. I agree, whatever reason you might not study it because of, but then once you are studying it, then only you will have questions. Then only it's it's some sensical part to actually explain it to you again. Fine, whatever problems you are having, then we will be discussing it. Fine. Umayma, please turn on the camera, bache.
Yes, ma'am. 1 minute.
हाँ. I quickly want to discuss one point which I'm not very sure of whether I've discussed it here or not. That is regarding the ionic bonds. So I will quickly discuss that here. Then, inshallah, we'll be moving on to the this thing, the fourth chapter. Okay. Umaima, should I start, bacha? Are you ready?
Yes, ma'am.
Okay, okay. And that point is regarding the ions, okay? So please pay attention, bacho. Now, what are ions? Ions are simply, let's suppose we have this one atom. This has one atom. It becomes charged atom. It becomes charged atom. This will be called as ion. Okay, this will be called as ion. Now, there's second form of ion that can be molecule. What is molecule? Group of atom, right? It becomes charged. Okay, it becomes charged. It is called as polyatomic ion. Yes, polyatomic ion, simply because it was a molecule. So obviously it is having a group of atoms. Now group of atoms could be referred to as the polyatomic ion. Therefore, it will be called as a polyatomic ion. Fine. Now the ions, whether it's of a single atom, Ali, whether it's of a single atom or it's of a molecule, okay, that means a polyatomic ion could be of two types, either cation and anion. What was the cation? When the atom is become positively charged. When the atom is becoming positively charged. And when is the anion being formed? When the atom is becoming negatively charged. Fine. When the atom is becoming or the molecule is becoming negatively charged. Fine. Now the main point here is that let's suppose we are talking about just single atoms. We are talking about single atoms, okay? This was the atom. It changed to the cation. It changed to the cation. This is atom number 1. This is atom 2, okay? It changed to anion. It changed to anion. But so please pay attention. Generally, the atoms which will be changing to cations are metals. What are they? Are metals.
Metals.
Generally, the atoms changing to anions, that is gaining negative charge, are
Non-metal.
Non-metals.
non-metals. Fine. Now see, once the atom has changed to the cation, here I'm definitely talking about the metal atoms, right? Metals, when they are changing to the cations, or the simple atom which has changed to the cation, its name will not change. Its name will not change. Example, let's suppose we had a sodium atom. It changes to the ion. I will still call it as the sodium ion. I will still call it as the sodium ion. Fine. Let's suppose I have a potassium atom. This was the atom. It changes to potassium K plus. That is, it has, you can clearly see it is becoming a positively charged ion, right? What will I call it as? I will call it as a
Potassium ion.
potassium ion. Fine. K plus potassium ion. Clear? Fine. But let's suppose what really happens with the anions. Let's quickly see that. This is the oxygen atom. What is this? This is the oxygen atom. And you must know till now that oxygen is a non-metal. Oxygen is a non-metal, okay? It will form the anion. What will it form? Anion. O2 minus. It will form the anion. You can clearly see from here that it's a negatively charged ion. Therefore, it's an anion. Therefore, it's an anion, right? What will it? What we will call it now? It is changing from the oxygen atom. Earlier, it was an atom. Now to the ion. And what will I call it as? I will call it as the oxide ion. What will I call it as? Oxide ion. Just what I'm trying to tell you here is that whenever the atom is changing to the positive ion, that is the cation, their name generally do not change. We just add ion instead of the atom. We just add ion instead of the atom. The second is whenever the atom is changing to the anion, okay, their name will change. Their name will change. I'll take one more example. So oxygen atom changing to the oxide ion, sulfur atom changing to the sulfide ion, right? Phosphorus atom changing to the phosphide ion, the nitrogen atom changing to the nitride ion. All of these are examples of this. Chloride, bromide, iodide, okay, fluoride. All of these are examples of non-metals changing to the anions with their names being changed. I hope the point is clear to everyone.
Ma'am, should we learn the names?
So,
But with practice, you will know this, okay? With practice, you will know this. So some of them you should actually know. Like it is very obvious oxide means it's coming from oxygen. Fluoride means, I mean, fluoride is not that common. Chloride means coming from chlorine, okay? Sulfide means coming from sulfur and nitride means coming from nitrogen. These four are more important for you, okay?
Okay, ma'am.
Fine. Now coming to the next point. Once we have the cations and the anions. Once we have the cations and the anions, okay? This is an ion, this is an ion, okay? One is a positive one, the other is a -1. The other is a -1. What type of bond will they form between themselves? What type of bond will they form between themselves? The bond here will be the ionic bond. What
Ion-
bond? Ionic bond.
Ionic bond.
And the compound here will be the ionic compound. What compound?
Ionic compound.
Ionic
Compound is very simple. Compound, we know different elements combining together. Here, elements are combining in the form of ions, therefore it is called as an ionic compound. I think it should be very clear, right? Ionic compound. What is it? Ionic compound. Also called as electrovalent compound. Okay, electrovalent compounds are the bond. Fine. Now the main point here is that let's take the example here. Let's take the what type of forces are between them. So electrostatic forces of attraction. What forces? Electrostatic forces of attraction. We know that between a negative charge and a positive charge, the electrostatic forces of attraction exist. So what charges are there? I mean, what force is there? It is the electrostatic force of. Clear? I hope no problem till here. If any, please say. And this force is very strong, basically. Fine. Now let's suppose I have this sodium atom and I have this chlorine atom. Okay. This loses the electron. This is not for you right now. Just understand this one. This loses this electron and forms sodium plus. So what will I call it as? Sodium ion. What will I call it as?
Sodium ion.
This gains one electron. It forms
So it's
chlorine minus. Sodium ion, which is fine. Now what will I call it as? Cl minus. What will be the name of this? Chlorine ion.
Chlorine ion.
chloride.
Chloride ion.
Chloride.
What will it be? Chloride ion. Now these two will form a bond here. And this will become what? The ionic compound. Well, what will it become? The ionic compound. So here the bond is formed by the ionic, the bond is the ionic bond. And how is the ionic bond formed? By the transfer of electrons, by the transfer of
Electrons.
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 Yeah. You can clearly see one is giving, the other is taking. That is why one is gaining the positive, the other one is gaining the negative. Fine, fine. So here the bond is formed by the transfer of electrons. The next important thing, if I ask you, but I just give you this, huh? If I ask you what ions are the constituting ions here, what ions are the constituting ions here, what will you say?
Sodium and chloride.
Sodium ion and the chloride ion, correct? Sodium ion and the chloride ion. But if I ask you what elements are combining together to form
Sodium
this?
and chlorine.
Chlorine, okay. Then you will say, because we are talking about the elemental form then we are talking about the elemental form. Are these points clear?
Yes, ma'am.
Yes, ma'am.
Fine. And also, when we were learning making chemical formulas, we are learning to make chemical formulas when ionic bonds are formed, when ionic compounds are being formed. See, let's suppose I am having sodium chloride, +1, -1. What is the basis of this compound? This is the ionic bond, right? That's the ionic bond, cation and anion, simple. So these type of bonds, these chemical formulas that we have learned, they are for the ionic compounds. Clear?
Yes,
The other type of compound that we have, the other type of bond that we have, major one is the covalent bond. What is it? Covalent bond. Okay. Covalent bonds, say ionic bonds, what was the in what manner were they joining together? Can I say by the transfer of electrons? Covalent bonds are forming because of sharing of electrons. Because of sharing. That's it. Okay. Those are the points I wanted to discuss. Clear? Any problem
Yes,
here?
ma'am.
Anyone?
No.
Anyone, any problem? Abdullah, is it clear to you, bache? Umaima, clear?
Yes, ma'am.
Fine. Quickly tell me what are the ions here? Quickly, quickly.
Calcium ion and oxide.
Calcium ion and the oxide ion. Very good. What are the elements here?
Calcium and
oxygen.
oxygen.
Calcium and oxygen. Can you give me one example, Ali, bache? One example, any one example of the ionic compound other than these?
Ionic
No worry.
compound will be
Uh,
NaCl, like
Uh-huh.
from previous
mhm. Sodium chloride. Huh?
NaCl.
So basically,
Yes, sodium
yeah,
chloride.
sodium. Why is it sodium chloride? Because clearly it's an ionic bond, and what are actually constituting together is the ions, right? And sodium ion and the
Yes.
chloride ion. So we are naming it as the sodium chloride compound. Calcium oxide compound. I hope the point is clear. Constituting elements will be in the elemental form. Chlorine, oxygen, all of that. But here, when we are talking about the name of this compound, we will obviously be taking the names from whatever is making this compound. And who is making this compound? That's the calcium ion plus the oxide ion. Huh? Yes. So what will it be called as? Calcium oxide. Clear?
Yes, ma'am.
Rishikesh?
Yes, ma'am.
Oh, ma'am. Okay. Abdullah, Bacha, clear? You are not responding. Huh? Clear?
Yes.
Fine. Anyone, any problem in the in this chapter, or else we'll start with the fourth chapter.
Now we can start the fourth chapter.
Excuse me. What's the fourth chapter? Structure of the. And again, mind it, very, very, very important chapter, fundamentally very important, conceptually very important for rest of the chemistry. The chemistry basics foundations are here in the third and the fourth chapter. So please study them lightly. Okay, fine. Now, I would quickly want to give you the context of this chapter. What is it that we'll be dealing with in this chapter? Fine. In the third chapter, we were able to establish the importance of the atom. With everything, we found out that it is the atom which is basically participating in the chemical reactions. Right? It was the atom. And then we tried to learn about something, the shape, the size, the symbols of the atom, the mass of the atom, right? And then we also found out, we tried to understand in what manner is the atom existing. And then we found out that the atom is existing in the molecular form, either the molecule of element or the molecule of compound. And if not the molecule, it is in the ionic form, right? It is in the ionic form. And then we found out that if it is in the ionic form, in what manner it is combining, right? In what manner it is combining. And once we have got the molecules, the formula units, we were also able to understand how to calculate their molecular masses. This is what we have studied in the third chapter. I hope all of you will agree with this.
Yes, ma'am.
Right.
Yes, ma'am.
In this chapter, we'll be deep diving into the atom, within the atom. We have studied everything about the atom, like the shape, the size, all of that, how is it existing? Fine. Why is it that atom is giving these properties? And for that to be understood, it is very important for us to understand what is inside the atom. What is inside the atom, right? And that we call as the structure of the atom. I would again use a very simple example here. Please try to understand it. Let's suppose I'm taking any meal, right? Any pizza. The taste of that pizza would be because of its ingredients, right? The taste of that pizza would be because of its ingredients. If I know those ingredients, I'll be able to understand why is the taste, a specific taste, right? That is a simple point here. Now, once we have understood certain different properties of the atoms that we have seen, why is it combining in a particular manner? Why is it forming the ions? Why metals are forming the cations and why non-metals are forming the anions, right? All of these are the questions that we have seen. But for them to be answered, we need to deep dive into the structure of the atom. What is it within the atom that is giving atom these different properties, these different behaviors? So this is what we are going to study. Tell me, is the context of the chapter understood? Is the context of the chapter understood?
Yes,
Yes, ma'am.
ma'am.
Fine. Now, see, in this chapter, we have two important parts. One is the historical perspective, the historical development, the different models that we had for the structure of the atom. Okay. And then once we have established the structure of the atom, as in the particles within the atom, then we are learning about their arrangements in the atom. I would want to take the second part first. I would want to take the second part first, but I would want the assurity from all of your side that none of you are having the exams for this chapter in the next 1 month. Then only we'll be able to take it like this.
No, ma'am, we do not have.
Fine. Rishikesh, are you having the exam in the nearby, like in a
No,
month
ma'am,
or
it's in
like
December.
Fine, fine. So till then we'll be able to complete this chapter. And the reason I'm saying is that because I'm taking the second half first. Fine. But I would request you to be very attentive, okay, and focused. From the third chapter, we saw there is the atom. This is the atom. And through various experiments, observations, and practicals, we were able to establish this, that there are three subatomic particles that is within the atom. Okay, within the atom, there are three subatomic particles: electron, proton, and neutron. What are they? Electron, proton, and neutron. electron, proton, and neutron. So basically, once we are trying to understand the atom, we have to understand the properties and the characteristics of these three subatomic particles, the electron, the proton, and the neutron. Let's quickly see some of the properties here. Let's quickly see some of the properties here. So electron, proton, and the neutron. We'll be seeing three major things, okay? The charge, the mass, and the location. So the charge, the mass, and the location. Okay, location, this is within the atom. Location within atom, right? The electron has a charge of minus E. We will discuss what is the value of E, but E here refers to the elementary charge. Okay, so there's some specific value. One electron is having minus E charge. Okay, whereas the proton is having plus E charge. That is the positive of the elementary charge. That is the positive of the elementary charge. Ali beta, be focused. If you miss this, it's very difficult to understand. Neutron is neutral. Neutron is neutral. Huh? Let's come to the mass. Okay, let's come to the mass. The electron basically is having a mass which is into 10 raised to the minus 31 kg. Minus 31 kg. This is 9.11 something into 10 raised to the minus 31 kg. Okay, minus 31 kg. Whereas for proton, we have 1.67 something something into 10 raised to the minus 27 kg. And for neutron also, we have a almost very equal mass, okay, very same mass, that is 1.67 something something into 10 raised to the minus 27 kg. If you are able to notice one thing here, that the mass of the electron is very small in comparison to the mass of the proton and the neutron. Do all of you agree with this?
Yes, ma'am.
Yes. Electron, leave the values, just see the powers. Okay, here electron is having the mass in the power raised to minus 31, whereas the proton and the neutron are having their mass in the power raised to minus 27. Can I say it's around 10,000 times smaller than the mass of the proton and the neutron?
Yes, ma'am.
Rishikesh,
Yes, ma'am.
Abdullah, are you in the class? Beta, camera on.
Ma'am,
Huh?
do we have to by heart the masses?
No. I'm just telling you, as of now, no. As of now, no. In the next classes, you will be knowing it, but as of now, no. Okay. Now the location. Come to the location. Location of the proton and the neutron is in the nucleus. But we'll be discussing all these terms, so don't worry. Okay, nucleus. The proton and the neutron, they lie within the nucleus, in the nucleus. And the electrons lie on the shells or the orbits. Shells or the orbits. Okay, shells or the orbits. Now let's quickly see what do we mean by the elementary charge. I'll be discussing each and everything here, so don't worry. So E basically, which is the elementary charge. What is it? Okay, the elementary charge. What is the value here? 1.6 into 10 raised to the minus 19 coulomb. I'll write it properly so that you don't have any problem. Coulomb. I hope you know that coulomb is the standard unit of charge. And here we are talking about the charge. So coulomb. If I'm saying electron, the charge on one electron will be minus 1.6 into 10 raised to the minus 19 coulomb. Whereas the charge on one proton will be
1 coulomb.
The charge on one proton will be
1 coulomb.
plus 1.6 into 10 raised to the minus 19 coulomb. We have written it there, it is plus E. And we're taking the value of E as 1.6 into 10 raised to the minus 19 coulomb. Okay, bacho? Fine. You don't have to go into the details as this. I'm just telling all of you, this to just to explain you. Fine. Is it fine now? Should we move on to the next point?
Yes.
Yes, ma'am.
Fine. Now, let's come to the next one. See. Charge is a property. Charge is a property. I hope you know this. Charge is a property. Some of the charges can be negative, some of the charges could be positive. Fine. If you want to understand it in the simplest form, just understand it like any property, like mass, okay, like the color. Some of the elements will be in a, some of the matter will be in a different color, some of the matter will be in a different color. But for charges, there are two types of charges, either negative or positive or neutral, none. Okay, so just understand it in that manner. Clear? Now see, let's suppose the charge on one electron is minus E, and the charge on one proton is plus E. Yes, plus E. So can I say, bacho, very important, charge on electron and proton are equal but opposite. Are equal but opposite. What did we write
Ma'am,
the
what about
charges?
neutrons?
Better they are neutral, huh? They have no charge. I just now said this. They have no charge.
Okay.
Charge on electron, we wrote it as minus E. Charge on proton, we wrote it as plus E. We can clearly say they are equal but opposite. They are equal but
Opposite.
Opposite.
opposite. Based on this, I'm just taking this example. Let's suppose I have 10 electrons. Let's suppose I have 10 electrons, huh? So the charge will be minus 10E because one electron is having a charge of minus E. But please say yes or no. Huh? And if
Yes.
I have
Ma'am.
10 electrons in the same, 10 protons in the same atom, don't you think I will have a charge of plus 10p? Because one proton has a charge of plus E, right? Plus 10E. So
Yes,
overall, don't
ma'am.
you think it will be neutral? Overall, don't you think it will be neutral? The atom I'm talking. Fine. The atom. Is it clear? Any problem, Umema? Any problem, bache?
No, ma'am.
Ma'am, previous year we had a question like this. Prove that why is the atom neutral as a whole?
It is neutral because the number of electrons and protons in the atom are equal, and the charge on one electron and proton are equal but opposite. This is the full answer for that question. Fine. We'll be learning it, inshallah. Fine. Now see, I'm coming to the structure of the atom now. The atom has a central nucleus, which is at the center of the atom. This part is called as the nucleus. Okay.
Yes.
Around the nucleus, we have shells or the orbits. Okay. Around the nucleus, we have the shells or the orbits. Please bear with my drawing. Okay. But just try to understand it. Okay. We have the shells or the orbits. What are these? The shells or the orbits. Now we have seen the location. So can I say protons and neutrons are here in the nucleus? Yes, we have just now seen that.
Yes, ma'am.
The protons and the neutrons are here in the nucleus. So that means they are at the center of the atom. They are present in the center of the atom. Where? They are present in the nucleus. Where is nucleus? In the center of the atom. Clear? Now the electrons are present on these shells or the orbits which are actually around the nucleus. So electrons are present here. Is it okay? Any problem till here?
No, ma'am.
And if I am going too fast, please let me know.
No,
Umema,
ma'am.
I
It's
think you are
quite
also
simple.
writing side by side, huh?
Yes, ma'am.
So if I'm going too fast, let me know, okay? I'll wait. Now see. Let's talk about the nucleus now. Quickly, okay? Let's talk about what is it that is present inside the nucleus? What is it that is present inside the nucleus?
Protons and neutrons.
So protons and neutrons. So they are overall together called as the nucleons. What are they called as?
Nucleons.
Nucleus.
Nucleons. Nucleon simply means anything which is in the nucleus. Anything which is in the nucleus, right? So that together, protons and neutrons together are called as the nucleons. Together are called as the nucleons. We'll be using this term quite often, so be clear with this term. Now, secondly, don't you think because of the presence of the protons in the nucleus, the nucleus will have a positive charge? Yes or no?
Yes.
Yeah. The nucleus will have a positive charge because of the presence of
Protons and
Protons.
neutrons.
Only protons.
neutrons, only protons. Neutrons are not contributing to the charge of the nucleus, okay? Neutrons are not
They
contributing to the
don't,
charge of the nucleus because they are
but they
neutral.
don't make a difference, right?
My question is, what is it that is making the nucleus positively charged? That's the proton.
Protons.
Okay, fine. Clear? Moving on to the next point. An atom is initially or by default neutral. What is it? Overall neutral. What do we mean by this overall neutral? See, it is having different charges in the forms of the electrons and the protons. It is having charges in the form of electron and proton, but overall it is neutral. Overall, it is neutral. Why? Because atom, we are obviously talking about one atom here. Atom has equal number of protons and electrons present in it. Okay. And we know that each electron and proton, they have equal but opposite charges.
Now
See,
in every single atom, there's like fixed amount of protons
yeah,
and
I'm coming to we are
electron.
coming to that. Yes, it is fixed. We are coming to that. Okay. See, we represent electron like this. Okay. You'll be knowing it, but a very simple point here. Fine. So electron and proton have equal but opposite charge. Have equal but opposite charge. Clear till here? Any problem, bacho?
No,
No,
ma'am.
ma'am.
Fine. Now come on to the next point. That is, how do we know what atom has what number of neutrons, protons, and electrons? How do we know what atom has what number of electrons, protons, and neutrons? We have understood till now, we have learned this thing till now that different elements have different atoms. That different elements have different atoms, and that same element will have the same type of atoms, right? One element will have the same type of atom present in it. So how are we able to differentiate that this atom is different and this atom is not different? Okay, that is the question here. So we have to understand two parameters, two terms here quickly, and that is this. First is, but very important, atomic number. And mind it, these two terms basically will tell you everything about the atom. Through these two terms, we'll be able to understand the behavior of the atom. So atomic number. An atomic number is represented by a capital Z. What is it represented by? Capital Z, okay? And the atomic number of an atom, what am I saying? Atomic number of an atom, okay?
Atom.
Tells you or equals to, atomic number of an atom is the number of protons present in the atom. Number of protons present in the atom. Number of protons present in the atom. Fine. So Z, if I say, let's suppose Rishikesh is an atom, okay, and if I say that Z for Rishikesh is 12, okay, let's assume. So what does that mean? That Rishikesh as an atom will have 12 protons. Rishikesh as an atom will have 12 protons. Fine. Fine till here.
Yes, ma'am.
Yes, ma'am.
Okay. Now see the next point. If atomic number is the number of protons present in the atom, can I say the number of Z is equal to number of protons, which is further equal to the number of electrons in the atom? Yes. Which is further
Yes.
equal to the number of electrons in the atom. Why? Because we have just now seen that the atom, which is overall neutral, will have equal number of protons and electrons. Will have equal number of protons and electrons, yes or no?
Yes, ma'am.
Yes,
And the
ma'am.
next point that I'm going to speak is very important. Atomic number for an atom is its identity card. Example, what do I mean by saying this? See, let's suppose Ali and Rishikesh, these are two atoms, okay? Ali, Rishikesh, these are two atoms. If you both have the same atomic number, that means you both are same atoms. If you both have the same atomic number, that means both of you are same type of an atom, right? That means if I say that the element will have the atoms in which all the atoms of an element will have the same atomic number, is that statement correct? The atoms of a
Yes,
particular
ma'am.
element will have, all the atoms of a particular element will have the same atomic number. Is that
Yes.
statement correct?
Yes, ma'am.
Very good. Why is it correct? Because elements have the same type of an atoms. And how do we know that atoms are of same type? If their atomic number is same. If their atomic number is same. Therefore, if the atoms which are present in the element, in a particular element, all of them will have the same atomic number. Is it clear, bachcho?
Yes,
Yes,
ma'am.
ma'am.
Oh, ma'am, bachche clear?
Yes, ma'am.
Fine. Now, the next point, I'll quickly give the example here. That is, let's suppose Omama is one atom and I am different atom, okay? And we are having different atomic numbers. We are having different atomic numbers. What does that mean? What does that mean? We are same atoms or different atoms?
Different.
Different.
Can we be present in the same element? Can both of us be present in the same element?
No.
Yes.
Can we? But see, how can we be present in the same element if we have the different atomic number? See, well, don't worry, relax. See, what is happening? Same atomic number, that means same atom. Please try to understand this. Same atomic number, same atom. Different atomic number, different atom. Different atomic number, different atom. We know that an element has same type of atoms, right? An element has same type of an atoms. Therefore, for all the elements present in a certain specific particular element, the atomic number for all the atoms should be same. That is why they are same type of an atom. That is why they are present in the element, right? Is it clear?
Yes, ma'am.
And if I'm
Yes,
saying that
ma'am.
both of us being atoms are having different atomic numbers, that means we're not same type of atoms. That means we're not same type of atoms. If you're not same type of atoms, we cannot be present in one element, right?
Yes.
Clear?
Yes,
But we can be
ma'am.
present in the compound in a fixed ratio. We can be present in the compound in a fixed ratio. Clear? Clear till here, everyone? So you can write
Yes.
it. Atomic number. Atomic number is more of an. You can write this in your own words, whatever you have understood. Okay, basically tells you the atom is same or not. Okay. Atomic number defines, tells you, indicates you whether the atom is same or not. If the atomic number is same, the atom is same. Ali, are you writing all of this?
No, ma'am.
No. And then you will ask the question, same questions in the next class. You know, I agree. To listen all of this is very interesting. For any subject, that is true. And then you feel okay, everything is understood, everything is understood. The point comes when you sit for revising and then you are blank there. And if you cannot revise, then again, nothing is like there's no use of anything. Okay. So writing always helps. Writing will never disappoint you. Write it, all of you. Write it. I'm waiting. Ma'am, any problem, please ask. Abdullah, done, bacha?
Yes, ma'am.
Ali, when you're done with it, please let me know.
Done, ma'am.
Right. See, the next very, very, very important point that you should know here is that when we are having the periodic table, okay, the elements are arranged in some order. The elements are arranged in some order, and that order is nothing but the atomic number. But the atomic number. So you can write it. Elements are arranged in the order of their atomic number.
Now we are talking
And why
about
am
the
I
periodic table.
obviously where else are the elements arranged? If we are talking about any other thing, then that will be specified. Example, the reactivity series, that is for metals, right? We are talking about the elements. You can write it in the periodic table if you want, just to be clear. Fine. And why am I saying elements are arranged? Because obviously the atoms, the same type of atoms which are having the same atomic number will be constituting elements. Ultimately, it is the elemental form which is existing, right? Which is a form of a molecular form again. So we have the elements then. But you clear? We are talking about the atoms of particular elements. You can understand it in this manner. Done, bachcho, done? Rishikesh, bachcho, camera
Yes, ma'am.
should be
Yes,
on.
ma'am. Done.
Yes.
Fine.
Yes, ma'am. Done.
Fine. The next thing is the mass number or the atomic mass, you can say. Okay, and it is represented by a capital A. What it is represented by? A capital A. Okay. Now through this you can tell me what do we mean by this? What is atomic mass? What is atomic mass here?
Mass of an atom.
Mass of an atom. What is mass number then? See, let's quickly see.
Mass number is also
When all of you are done writing, let me know. I'll be explaining this. Please don't miss it.
done.
Rishikesh done? Fine, fine. See, we just now saw that the atom has 3 subatomic particles. One atom, each atom, an atom has 3 subatomic particles, namely the electron, the proton, and the neutron. It is very clear that whatever number of neutrons are there, whatever number of protons are there, and whatever number of electrons are there in the atom, all of their mass combined together will be giving you the mass of the atom. Right? Will be giving you the mass of the atom. Example, if in a cricketing kit I have 3 bats, 2 balls, helmet, all of that, I'll be taking the mass of each of that and I'll be adding it, and then I'll be getting the mass of that cricket kit, right? In the similar manner, I'll be getting the mass of that atom once I've taken in the mass of each number of all the subatomic particles in whatever number they are present. Let's suppose I've got 5 electrons. So I'll take the mass of those 5 electrons. Let's suppose I have 10 protons. So I'll take the mass of 10 protons, right? And then I have 10 electrons, 10 neutrons. Okay, I'll take the mass of 10 neutrons. I'll add all of them together. I'll get the atomic mass. Is it clear? Yes, that is something that will be happening. But
Ma'am,
that does not happen in that way. Yes.
ma'am.
Huh? Yes.
Isn't atomic mass calculated with only protons and neutrons?
That's what I'm coming to. I'm saying that does not happen. That does not happen. See, we saw that the mass of the electron is very, 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 very small in comparison to the mass of the proton and the neutron. So much so that it is negligible in comparison to the mass of the proton and the neutron. What is it? The mass of electron is negligible in comparison to mass of proton and neutron. The mass of the proton and neutron is almost equal. There's just difference after the point, right? Now, therefore, the atomic mass is just due to what? Protons and neutrons present in the atom.
So, ma'am, we won't include electrons while calculating the mass number.
Yes, we will not include that. Okay, and that's what we are coming to. Okay, how do we get the mass number? We are coming to that, present in the atom, right? Done, bachcho?
Yes, ma'am.
Yes, ma'am.
Therefore, can I say it is the nucleons which is actually contributing to the atomic mass? It is the nucleons which is contributing to the atomic mass. Nucleons, you remember, anything which is present inside the nucleus. And what is present inside the nucleus? The protons and the neutrons. Now, the number of the number of the neutrons and the protons, basically the number of the nucleons will be really affecting the atomic mass. It is the total number of the nucleons which will be actually deciding the atomic mass. Yes or no? Yes or no?
Yes, ma'am.
Yes,
So can
ma'am.
I say that atomic mass, which is nothing here but taken as this atomic mass, is nothing but the number of protons into the mass of the proton, right? Number of protons into mass of proton plus number of neutrons into mass of neutron. Yes or no? Yes or no?
Ma'am,
Yes.
mass of singular neutron, right?
Yep. And we are multiplying by the number of neutrons and protons respectively, right?
Yes, ma'am.
Huh? Therefore, mass number is nothing. Mass number of an atom, I'll write it properly here. Mass number of an atom is nothing but the total number of nucleons present in the atom. Total number of nucleons present in the atom. Why is it that we are taking it like this? Because we know that the mass of the atom is just happening because of the total number of the nucleons. We know this, right? Because we have neglected the mass of the electron. So it is the total number of the nucleons which is really deciding the mass of the atom. So what is mass number? The total number of nucleons present in the atom. The total number of nucleons present in the atom. Therefore, A, which is nothing but the mass number, we have seen it, right? We denote it using A, is nothing but neutrons plus protons number. Is it understood, bacho? Is it understood? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any problem? Let me know.
No, ma'am.
Abdullah is left the class.
Mhm.
Yes. Okay. So let's suppose we'll quickly take an example here. Let's suppose, bacho. So we have got to know the number of protons, and through that we have got to know the number of electrons present in the atom, and then we have also got to know the number of neutrons present in the atom through the total mass number, which is denoted by A. So let's quickly take the example here, bacho. So the question is Z for an atom. Achha, we always write it like this. See, let's suppose I'm taking any atom. Okay, let's suppose I'm taking any atom which is symbol of the atom. I'll just write symbol of the atom here. Okay, any atom's symbol. So I'll be writing A here and I'll be writing Z here. Okay, example, I take the oxygen. Okay, I take the oxygen here. Okay, what is the mass number for oxygen? What is the mass number for oxygen? That is nothing but its atomic mass. And what is the atomic mass of an atom? Oxygen atom?
16.
16.
Excellent, 16. And what's the atomic number for oxygen? That is 8. Okay, so we'll be writing it like this. Is it okay, bacho?
Yes,
Yes,
ma'am.
ma'am.
Now, through this, you can quickly tell me the number of protons, the number of electrons, and the number of neutrons for this atom, for the oxygen atom. Just by looking
Ma'am, is it
at this.
8?
8 is the number of protons
Neutrons,
because that
8 neutrons, 8 protons, 8 electrons, and 8 neutrons.
neutrons. Very good. Okay. Now let's take some other example. You see, this is just a coincidence that all of the things are coming out to be equal. Okay. This is just a coincidence. Fine. The next thing, let's take the for sodium. Okay. The atomic number for sodium is 11, and the what's the atomic mass for sodium?
32.
32.
23. 32 is for sulfur. Okay, 23,
Sulfur,
32 is for sulfur. Fine. Now quickly tell me the number of protons here. Number of protons here, all of you. Protons.
11.
Ali, Umaima, बच्चे protons, number of protons here. Umaima, बच्चे, see, do not hesitate. If it is not understood, ask without any hesitation.
Ma'am, it's 11.
Okay.
It's 12.
Why is it 12?
Yes.
See, no worries. We are talking about the number of protons, okay? I've talked about the number of protons. Leave everything, the neutrons, electrons, leave that. We want to know the number of protons, okay? The number of protons. And for an atom, bache, the number of protons is always denoted by its atomic number. What is it denoted by? The atomic number. And what is atomic number? Atomic number is nothing but denoted by Z. Huh? Atomic number is nothing but denoted by Z. And here, what is the value of Z for this sodium atom?
11.
11. Ali, but just a second. Oh, my, yes. What is the value for Z here for the sodium atom?
It's 11.
11. So can I see based on that number of protons are 11? Okay.
Yes, ma'am.
Clear? Any problem?
No.
No. And number of electrons. Let's talk about the number of electrons. In an atom, the number of protons and electrons are equal. They are equal, right? So what will be the number of
Yes,
electrons here?
ma'am.
Again,
11.
11. Umema, is it clear how are we getting 11 for electrons also?
Yes, ma'am.
Fine. Now come to the number of neutrons. Number of neutrons. No one will answer. Number of neutrons. What is the atomic, what is the mass number here? What is the mass number here?
23.
Umema, what is the mass number here? Can I say it is 23, right? Because the value of A here is 23. 23 is the mass number. Now, what is it equal to? The number of neutrons and protons. The number of neutrons and protons, right? The number of protons, can I say, can be equal to Z, right? And then 23 is equal to number of neutrons. What is the value of Z? You know that. What is it?
Yes.
11.
It's
11.
11.
So, N, that is the number of neutrons, will be 12. Yes, the number of neutrons come out to be 12. Is it clear?
Yes, ma'am.
Yes.
Anyone, any problem here? Please say.
Ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
Let's talk about, tell me the number of electrons, protons, and neutrons for aluminium. For aluminium. I'll not tell you the atomic mass, I'll just tell you the atomic number. And Z here is 13. Okay. Who knows the atomic mass for aluminium? Hmm. 27.
Ma'am, is
Is
it
it 27?
26?
27, but 27 U. 27. Okay. 27 U. Someone is fine. Excellent. हाँ जी बच्चों, done.
Yes, ma'am.
Very good. Number of protons?
It's 13.
13. Why are we taking it as 13? Because it is the atomic number, right? And
Yes,
what is
ma'am.
atomic number? Atomic number is nothing but the atomic number itself is nothing but the number of protons in the atom, right? Therefore, it is 13. Very good. The number of electrons?
13 because it's equal to 4.
Protons number. Excellent. 13. And what we will get as the number of neutrons here?
No, I got 14.
14. Huh? Ma'am, what's the answer for neutrons?
14.
14. Excellent. How are we getting 14 and why are we getting 14?
Because neutron will be
27
equal.
minus 30.
The total number of nucleons is 27. That is the mass number. Mass number is nothing but the total number of nucleons. And 27 is equal to number of neutrons plus 13. Neutron plus proton. Therefore, neutron is equal to 14. Excellent. Anyone, any problem, please tell.
No.
Fine. So then we are ending it here today. In the next class, we'll be continuing from this topic. I would not want to revise all of these again. Please revise it and then come. Barely will take 5 to 10 minutes. Fine.
Okay.
Thank you.
Thank you.
That's right.